So I'm here in Ireland at Smithstown Light Engineering. Lee, quite a story that's unfolded here over a period of years really, hasn't it? I mean, what's happened? Why has this machine been installed behind us here that we're going to look at in a minute?
It's not unusual for us to take a period of time to engage with a customer, develop a relationship and ultimately sell a machine. But Smithstown Light, Brian and Gerard King both went over to EMO, I think it was 2016 or 17, and they stumbled across Bumotec and they started to look at why does this machine look like it does, what's its capability. They didn't have work at the time for it, and then over time they started to show us components, you know, does this fit, does that fit, and eventually we found the perfect part for the machine. And they came to see us at Mac and they purchased one.
But it's like you've said to me that they first saw it and it sort of plants a seed, doesn't it?
It does.
Because what the audience are going to see in a minute with this machine is highly capable. There's lots going on, there's lots of options. But I guess when you first see one, you might be blown away by what it's capable of. So immediately you can't necessarily apply a part to it. Is that right, or is it?
Well, it is, and we call this machine the Swiss Army knife. You know, it's got a function that does everything within the machine, depending on how you configure it. So a lot of people will buy a turning machine, or they'll buy a milling machine, or a grinding machine, and this does everything, and it does it all automated, and it does it all in one setup, and you can change between parts, you can change between workpieces, materials and everything without any intervention.
Let's have a look. I mean, we'll get the camera closer to the machine as well, but what was their sort of application? What was the requirement then? What was it after this seed had been planted that a few years down the line they went, right, that's it, that's the machine?
There's two things we look for when we're looking at components for this machine, and it's accuracy and complexity. So if a part's complex, if it's 50% or more milled and then the rest turned ground, and it's micron-accurate, then it's perfect for this machine.
Yeah. So it's medical sector though, wasn't it?
For sure.
Yeah,
so luxury goods, medtech, aerospace, avionics, they're the typical industries that we go for.
And when you look in the machine then, so we've got two spindles, okay? So we've got spindle on what at the moment it's actually in a what you'd class as like a vertical or upside down position, as opposed to opposing.
Well, it's in a parked position at the moment, so your main spindle is fixed.
Yeah.
You've got 6,000 revs, and you can either bar feed in. So on this machine we've got a 3-metre bar feeder. We're driving bar through the main spindle and we're producing the first half of the component. The sub-spindle can either be used in a vertical or horizontal position, so it comes from its park position, swivels up into the horizontal position. Once the first half of the job's done, we part it off, so it's held in the sub-spindle. We finish it then in the sub-spindle.
So when the bottom spindle's in that position, that's really then for the milling spindle to come in and do its operations, isn't it? It's being positioned in that park position to hold the part so that the milling spindle comes down and does its machining.
So the milling spindle can operate with the sub-spindle vertically, yeah, but we can also move the sub-spindle around horizontally and machine as well. So you can bar feed in, you can actually use the sub-spindle to pull the bar out and hold it between two ends, yeah, or you can do your first part in your main spindle, second part in your sub-spindle. It's very versatile. You can do whatever you want.
And what was interesting for me about talking to the guys here is this is their MPI area, isn't it, as they call it? So this machine is being used for when they get the potential of a new project. This is where they run the parts, or they look at this machine to be able to create a new process that's really, really efficient because you've got all these opportunities, and then it could go into production.
Absolutely. So this has been here just for a couple of 3 months now. So they are they're introducing new products, they're learning the machine, they're developing the processes, then they go into production. So it's at the moment it's almost like a tool room machine, yeah, but in the future it'll be making production parts.
The tooling area then, we talk about the milling spindle. I think you mentioned to me 42,000 RPM, HSK 40. Is that right?
It is. So the standard option is 30,000 revs. This is a higher speed option at 42,000 revs. HSK 40, or we also offer Capto. The tool change system comes in 3 levels, 30 tools per level. So in this case you've got 60 tools, you could have another level for 90 tools. and you've got tool breakage in there as well. I mean, another interesting thing to point out in here, at the back there's actually a tool changeable gripper that's pneumatically controlled, and that's for handling workpieces.
Okay, we'll come to that in a minute. When I see here then, you've got turning tools, parting tools, milling tools, so you've got obviously tools for both of those disciplines all held in this carousel.
It's a mill turn grind machine. So the spindle's 40,000 revs, it's ceramic hybrid bearings. It's then got a hearth system within the spindle that disengages the bearings when you're turning. So you've got 8 positions on the hearth that you can orientate the tool. You're not touching the bearings or damaging the bearings. You can heavy turn on it, but then you can also high speed, very accurately mill on it as well, up to 40,000 revs.
What's happening, I mean, we can't see it, but in here you've got then, this is where your workpiece changer is too. So not only have you got a bar feed on this machine, which is feeding bar, you've also then got a workpiece changer to the right here, which will hold components that you can pick up in the machine too.
Well, let's go and have a look at that.
Yeah. This also illustrates, Lee, the footprint of the machine is
It's very small. It's a very compact machine.
Yeah.
So in this section here, you've got up to 20 trays, if you like,
yeah,
that you can store. You can either store finished parts, or you can actually take raw material, load it into the spindle, manufacture it, and then put the finished part away.
Yeah.
Or you can actually store collet systems, and a machine like this can automatically change between collet systems, so you can go from one workpiece to the next workpiece completely unmanned. So there's lots of functionality within this, so it's automation within the machine.
Is there a scenario when someone's using the bar feed and using this for the same
Sure.
job?
So you can bar feed in through the spindle, make your part, put your finished part in here. Or if you've got, say, additive parts, you can pick the additive part from here, machine it, put it back in here when it's finished. So it's fully automated.
And are these all things that are like option? You know, as you're specing the machine out, you want the automatic work changer, you want this, you want that. Is that how you go about?
But do you know what? When people buy a machine like this, it's a workhorse. They want to run it 24/7. So very rarely do we sell a machine without a bar feeder or without the automation tray system.
Yeah.
So you know your spindle's turning, you're making money.
Well, we see the spindle going up here now in this position.
Sure.
Here. Is there a different variance in the machines where you don't necessarily have the back spindle as well, and you just have one on the front and the milling spindle and a tail stop or something like that?
There's different ways to configure the machine. So the back working, as we call it, can either be a main spindle that you've got there. It could just be a centre.
Because that's what I would associate with a traditional twin spindle machine, isn't it? We see here them kissing as they're parting apart off. And that's what when you talk about twin spindle, that's generally how you visualise.
And it's the most common configuration for us. But you could have a vice on there, you could have a centre on there. You can configure the machines in different ways. And then we've got an operating system with FANUC 31i control, big screen. We've got a lot of Bumotec functionality sitting behind the FANUC system for managing the automation, for managing the tooling. It's a very easy machine to operate.
And with so much going on in the machine, I mean, it must generate a lot of heat. How do you keep it all kind of cool and thermally stable?
Well, we control the temperature of the fluid, but more importantly, we actually control the temperature of the machine. So around the spindle and around all the axes, we've got cooling systems.
One of the guys we were talking to earlier was talking about the fact that his confidence once he's run one off to know that 200 off every single part's going to be the same right the way up to the end. So that obviously talks about accuracy. What are you able to chase here in terms of accuracy on the machine?
Well, there's two things on this machine really. There's rigidity and accuracy. It's a very small machine, but it's actually a cast iron construction, and it's got linear drives, linear motors. So it's a very rigid machine. It's highly accurate. It's a 2 micron accurate machine across the full length of any of the linear axes. And of course, it's a 7 or 9 axis configuration depending on how people want the machine configured.
But the linear drive motor technology, so there's no ball screws in this anymore.
No, so it's linear drives.
All axes linear drive motors.
All linear axes, yeah.
Oh.
And then of course you've got your rotary axes as well. But
Yeah.
so it's a it's a super accurate machine. We also
You can see the just shot out of shot there, but it's interesting to see how that comes
Sure.
in, and everything's down to point something of a second for the tool changing and all of that, because again, I guess you don't want any non-cut time, do you? Everything's got to be in process.
But yeah, it's a very well engineered, compact, accurate, heavy-duty machine for complex parts.
In this neck of the woods, the medical sector is obviously massive, isn't it? We've been here a few times for yourselves. But this must be quite a statement for you and your company to have this machine in here now, because Gerard even said earlier, once there's one machine, there's a plan in place already for a lot more.
And that's what we hope for. So Smithstown is a famous name in this area within the medtech sector. Very, very professional, high-end company. So we were delighted when they chose us. And the way that the market's going now is more complex, higher accuracy parts. So this is the perfect machine for those kind of applications.